Hello, this lesson is for congruence and overlapping triangles. This lesson will teach me to apply CP-CTC to complex diagrams. Just a refresher, CP-CTC stands for corresponding parts of congruent triangles are congruent, and then proving triangles are congruent. All right, so here's some information. If you look at both of these diagrams, they have the same diagram and the same given information, but I'm asking that you prove different parts to be congruent. So the biggest question you first have to deal with is which triangles are you trying to prove? So let's go through and mark our given information. Let's see, it says that PQ bisects angle RPS. So PQ is cutting RPS into two congruent pieces. So we know that to be true. Then it says, let me get a different color, that PR is congruent to PS. PR is congruent to PS. All right, now it's asking for me to prove that angle RTP, this one right here, and STP, this one right here, are to be congruent. So that's what it wants me to prove, so I'm not really going to mark it. What I see though is I know that PT, this line right here, is congruent to itself based on the reflexive property. So what I'm seeing is when it asks to mark with a star which triangles you're proving, I'm going to color them here with some crayon. I need to prove that this triangle here is congruent to this triangle here. If I can prove that those triangles are congruent, then by the idea that if the triangles are congruent then their parts are congruent, then I can get what it's trying to prove. So for letter A, it says mark with a star the triangles you're trying to prove. It's the one I colored in red and the one I colored in green. Which triangle will be the one you need to work with? Well, it's going to be triangle PTR needs to be congruent to triangle PTS. Mark the given information, we did that. And letter D says, how will you prove the needed triangle is congruent? I see side, angle, side. So these are going to be congruent by side, angle, side. So when using CPCTC, if we were to write out a full proof, we'd be able to prove that those pieces are congruent. Looking at number 2, given PQ bisects angle RPS, well that's here and here. It says again that PR is congruent to PS. And look at what it wants you to prove. It wants you to prove this time that RQP, so this angle, is congruent to SQT, so this angle here. So it now wants these angles to be proved congruent, so we need to use a different set of triangles. This time I'm going to need to prove that this whole triangle up here is congruent to this whole triangle down here. Whoopsies. So now when I look for the reflexive property, it's actually this whole line, PQ, since I need the entire triangle. So right there. All right, let's see if I've kind of answered all the questions down there. It says mark with a star the triangles you're proving congruent. Well, I need to prove that triangle PRQ is going to be congruent to triangle PSQ. Oh. I see side, angle, side one more time, and I'll be able to use CPCTC in order to, whoopsies, CPCTC, the idea that if triangles are congruent, then all the parts are congruent. Okay, so what's the purpose behind these two? You're not having to do a whole proof for these two, and what I'm getting at is that given information, there's multiple triangles in a diagram, so you need to use the given information and even take a peek at what you're proving to try to see what it is you kind of need to set up in this problem because the diagrams are going to get harder because there are multiple triangles in a diagram. I want to go back and just erase quickly this problem over here. Think about the number of triangles we really have in this diagram. And let me go back to getting that crayon tool. So we had this one up here that was marked and that one over there that was marked. So that was one pair of triangles. In the second proof, we had this top one and this bottom one, so it's a second pair. But did you ever consider that we also could have been working with this pair? So even in this one diagram, there were 3 different pairs of triangles we could have been dealing with, and it was in marking our diagram with the given statements that we were able to see what we were trying to prove. All right, so next one says in each diagram, the red and the blue triangles are congruent, identify their common sides. I think on your paper it says separate, redraw, and label. So we've seen this diagram before. And I know that you don't have a red and a blue, which is why they're highlighted. But if you notice, given the markings, I have a triangle here, and I have a triangle that is over here. So when these diagrams get complicated, sometimes it's not just a matter of triangles side by side, but they really truly are overlapping each other. So redraw them and label them. So I start up here with K, go down to M, N, back up to K. And I know that there's a point L there, but that point L is over on this other triangle that goes P, M, L over here, P, M, L. Identify their common side or angle. They both have an angle M, and that would be by the reflexive property. Looking at letter B, this one's not so crazy. We've got D, G, F would be one triangle, and we have E, F, D as that second triangle. I don't think this diagram is anywhere complicated at all. The idea of what they have in common right there, reflexive property, but sometimes it is helpful to redraw. And I know a lot of you don't like taking the time to redraw your diagram, but that's really going to be the key as they get harder. So looking at that dotted triangle, it's this whole one here. And looking at that solid triangle, it's this one over here. So these triangles are truly overlapping, they're crisscrossing. So redrawing them, especially in a proof, is going to make it easier because you're going to be able to mark things better. So that red triangle goes X, I'm sorry, this is Y, X, T, and then that blue triangle started with X, came down to Y, and over to Z. So X, Y, Z. And what do they have in common? They both have this X, Y in common. You can kind of see it right there. So overlapping triangles, letter B, not really overlapping. Letter A and C, completely overlapping because they crisscrossed. And even back to the original 2 examples, not so much that they're overlapping, but just more complicated diagrams. So what I have is when you turn your page, there are 3 proofs. These 3 proofs are loaded into a slide presentation in Google Classroom. My expectation is that you drag and drop. The QR codes are at the very end. Please, 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 please mark your diagrams on your piece of paper. These ones are hard to do on the computer. The computer drag and drop slideshow is really just meant for you to have all those options that I know you guys like. So my expectation is on your piece of paper that you are drawing and redrawing these triangles. So when it says, for instance, this here, here and here, and RT, it's really hard to mark RT because it's so long. So that's where you have to redraw the diagram, RST, and then I have STU, STU. So this is where you're now able to go back, and when it says mark that RT is congruent to US, it's in separating them that you're really able to mark them, because what happens is when students want to try to mark it on the diagram, they mark it here and then they end up thinking that you're talking about this piece, but it's not. It's really the entire length. So please, 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 please separate them, mark them, draw them, write on them, but do this on your piece of paper. This is too hard to do on your computer. So do it on your piece of paper. You'll drag and drop all of your options, check the QR codes. I don't have any paper QR codes available for you guys, so those of you with smartphones, if you could share with anybody around you, would be very, very helpful. But when you're done and you've checked that QR code, write actually out on your piece of paper so that your notes are complete. I get that I'm not there today, but this is your instruction. We'll go over everything tomorrow. Please do the best you can. Help each other, and I'll see you tomorrow. Thank you so much. Bye-bye.